Hi, welcome to Chapter 7, Section 3, Logarithmic Functions. Now, for the last day or so, we've been talking about exponential functions. And exponential functions are where the value of x is in the exponents. Now, there's an inverse to that. There's an opposite. Just like addition has subtraction, multiplication has division, well, exponential functions have logarithms. So mathematicians can find the value of your exponent by taking the log of the number. So you can have any base and any number, okay, but this time the base is in the bottom. So when I say log base b of y equals x, that's what I'm reading, where b is your base. It's the same base as if you were using the bottom number that had an exponent in exponential functions, so they can undo each other. You can rewrite a logarithm as an exponent. You can rewrite an exponential function as a logarithm. So let's go ahead and try that. Right? Let's go from one to the other. Because they are such inverses, you can just undo them. So, for instance, in example 2, we have base 2. So you'd write the base as a big number to the 4th power equals 16. And I really just work my way around like that, and it works every single time. Okay, if I want to write a logarithm as an exponential function like what you're used to seeing. For b, same thing. E to the 0 power equals 1. C, 12 to the 1st power equals 12. D, 1/4, right, because you can have fractions, that's 1/2, to the 1st power, to the negative 1st power, equals 4. Right? You can also go backwards. You can start with an exponential function and write it as a logarithmic function. Now here, you have to start everything with the word log. Okay? The letters L-O-G. So let's start that. Let's have log, and yes, that is an L. This is my base now. So I'm going to have a little 5, and that is a little 5. It is not part of the word log, right? It's not next to it. It's beneath it. It is a subscript. Now we're taking the log base 5 of 25, and that's going to equal 2. So again, I'm working my way around, starting with my base and going not with the one right next to each other. Let's do that again. We still have a log. Our base is 10, so we have a little 10 of 0.1 equals negative 1. Again, log base 8, so we have a little 8 of 4 equals 2/3. And that alignment is so important. Okay, you have to make sure you're putting it in the right spot. For D, we have log. My base is 6, so we have a little 6. We're taking the log base 6 of 1/216. Yes, you can do the same thing with with a fraction. And that equals negative 3. So it's very easy to go from one to the other and from another to another. Okay, so you can go back and forth because they're inverses. Now, for example 4, if you want to evaluate each logarithm, it's actually very simple. You have this wonderful calculator of yours that you can use in class, and if you hit Control and then 10 to the x, you can find your logarithm. You just have to put in the base that's there. So if you want to evaluate log base 4 of 64, you put it in your calculator, you get 3. Log base 5 of 0.2 is negative 1. The log base 1/5 of 125 is negative 3. And the log base 36 of 6 is 1/2. Now, if you have a base 10, right, they won't normally write log base 10 of x, even though we just did on example 3. Instead, they'll leave the base off completely. And if there's no base at all, you have to know, you have to recognize that that is the common log and that there should be, there's an imaginary 10. Just like when you have 1x, right? You don't write 1x, you write x, there's an imaginary 1 right there. So that's what your common logarithm is. It's log base 10 of x, and you write log x like you see below. Now, if you have log base e, right? We talked about base e last time. It's that special number. Well, it also has a special logarithm. It is called a natural logarithm. So if there's log base e of x, you will never see log base e of x. You will only see the natural log of x. Now, this is not in, okay? It is ln. When I write it, it almost looks like an lm because I write it in cursive. But that is ln, the natural logarithm. And it's reversed because the roots for a lot of mathematical terms is Latin. So they reverse them. Okay, it's ln, not in. And then we talked about how the logarithmic function is the inverse of the exponential function. They undo each other, just like addition undoes subtraction, multiplication undoes division, and vice versa. All right? So you have learned about logarithms. Have a great day.